I'm glad you clicked on this link because I have something I really wanted to share with you, and it's the slow reveal graph technique. It's a way for us to create an instructional routine that promotes sense making about data in our science classrooms. This highly engaging routine uses scaffolded visuals and discourse to help students make sense of data. As more and more of the graph is revealed, students refine their interpretation and construct meaning, often in surprising ways. This routine increases access for students without sacrificing rigor or engagement. So I wanted to walk you through an example. So for instance, if you just showed this to your class and you asked them various questions, you may think of other questions, but right now my gut says ask them, what type of graph do you think this is? Or ask them, what is this? And see if the kids will say something like, that's a graph. What type of graph is it? We'd hope to hear line graph, right? But there's all types of graphs. And we want them, if the very least, at least pick apart what they see. A box with line going this way. Just go real basic if needed. But get them to explain what they're seeing. And then move forward. The next thing they see are some numbers off on the right axis. So what can they see there? They see a 0, a negative 500, and a negative 1000. So now they may start making some interpretation of that line they see plus these numbers. So they have no idea what the numbers mean, and they're not necessarily sure what this line means also. They also may infer that the line is moving from the right to the left, and it's representing numbers that are changing over a certain amount of time perhaps. And you may ask them, what do you think is happening here? And most students, when this is revealed in this order, they will make the interpretation that the line is being read from the right to the left. And then if they know enough about negative integers, that we have something beyond negative 1000 moving up between negative 500 and negative 1000. So actually this shows they may infer that it is an increasing number. But rarely do students think, and this is a 6th grade graph, they may not get that data hasn't been obtained until the point in time there in the middle of the graph, and then is obtained from that point on. So show them another bit of information and see what they see. All right, so off the top, we see 1990, 1995, 2000. So it's quite likely the students would infer these are years. And now they can see from like 2000, 2005, 2010, time is going on. Now they may start putting this line in the correct direction. And you may ask them, what do you think, why is it starting just before 2000? And students need to know. Sometimes we will represent in graphs that data wasn't obtained until the year 2000 or just prior to the year 2000. And that's where it was started. And some data has been obtained and marked on this line graph. But why would it be like that randomly? And they may not quite get this yet, but you know that when you do things like this with a graph, that there's often a comparison graph somewhere next to it, above it, below it, that may have data starting in 1990 where this graph didn't start yet. But they don't need to know that yet. They're just going to start picking apart this graph. So now have them make some observations. So if data was obtained in 2000, just before 2000, what can we now say about this line representing these numbers? That is it an increasing number or a decreasing number? They should come up with somewhere before, let's just say negative 600 becomes negative almost 1500. Is that a increasing number or a decreasing number? It's a great time to start to talk about those negative integers as actually decreasing. So something is showing here decreasing over time from the years almost 2000 to beyond 2010. See how they're unpacking this with you? And you think of the careful planted questions to get them in this line of thinking. Reveal more. Now they need some info. Oh, okay, so off to the left, it's giving us information about those numbers on that axis. So it says erosion, and in parentheses, the meter. So we now know this is negative 500 meters, negative 1000 meters, erosion. So you can get back into reviewing what erosion means. What does erosion mean? Is that the movement of land from one place to another? You can have them pick apart what the word erosion means. And we're talking about meters. So So there's some measurement of amount of land moving from one place to another. And we're assuming land, maybe it's something else. But we now have some numbers and a unit. Reveal more. Change in land coverage over 25 years. Okay, so now they can start visualizing that there's a change in land coverage over this time frame, and you could say, is this a quick change over time? I mean, it's from 20. This one particular observation is just before 2000, and it goes to about 2015. So that's not 25 years. This graph doesn't go over 25 years, but if there was information elsewhere, so that might mean there's more information to come or another graph to compare to. But most importantly, we're getting change in land coverage. So is this a decrease in land coverage or an increase in land coverage? Based on the trending negative numbers, a decrease, negative 1,500 meters of land coverage, it seems like a decrease. So what would cause a decrease in land coverage? Erosion. It tells us right there. So this graph is giving us even more information. This comes from the 6th grade unit challenge, science challenge. It's found in Canvas. And 8th grade teachers have access to all the science challenges. This you find under Canvas. Go into the teacher toolbox and click CD sets, because these were once upon a time the CD sets that were on the DIAs. They were protected class questions, and we didn't really allow you to talk about them ahead of the test. But now you can. These are not protected. These are challenges that you should walk your student through. Now, this one's Unit 3, 6th grade. It's actually the very first one the 6th graders will see. It's a pretty challenging one. In fact, all the questions we have asking them to look at it don't have as much detail as we're unpacking with the slow reveal graph. Here's what it looks like. You open the page, there's some reading to do, and this is what the students have to take in. The graph that I am covering up right now, let me see if I can get rid of me here. Yeah, I should be gone now. Okay, the graph that I was on top of, the change in land coverage, the upper right-hand graph, this is the one we were unpacking together. Notice the information. Notice it's the gradual change. You're going to want the students to have come up with this information on their own as you walk them through the change in time. But we have 2 other graphs below. This is an amazing opportunity to ask some very, very purposeful questions. For instance, compare the graph that we just went over together to the one right below it. That's the one we went over. This was the erosion in Vietnam over time. The one below it's some erosion in Indonesia. So this is water coverage. You can see that in the graph we have the satellite images to the left, and in fact the reading explained that this is water coverage. And so how much land is actually still there over time. What is a significant difference between the graph on top and the graph in the middle? Notice just the nature of these lines. Both the second one and the third one are very different than the first one. You may ask them this question. Is there we see evidence of erosion over time. Do you see in any graph of the 3 graphs evidence of deposition? Have the students identify where deposition would occur in these graphs. Let this be a thoughtful question that they look at deeply. Don't give it to them too quickly. Of course, they should come up with anywhere in the graphs where there's a trend upwards in any graph and during any time where there's a trend upward where land was actually building. So that would be an interesting way to review deposition. Also, another really amazing opportunity within these graphs, not actually even asked during the science challenge, is do you see in any of these graphs a very significant event may have happened where there was either great deposition or great erosion happening very quickly? You want the students to process that, and they may note a couple areas in the bottom 2 graphs of a steep decline or a steep increase in erosion. And then something pretty cool to ask would be, what do you think may cause that? It depends on their background, but what particular event in nature could cause a huge erosion event. Now, maybe our students would come up with a hurricane. You know, if the Mississippi or Indonesia were hit with a hurricane, do you think there may be some increase in water over the land, therefore there's a decrease in land coverage? And they may come up with that themselves, they may not. But there's also an event called a tsunami, and they may or may not come up with that, but that's also a very quick event that water covers land very quickly. So in a quick reveal of this one, boom, let's see, click, click, there it is. I purposely did not reveal these two areas of information until I allowed students to make some interpretation of these events right here, these steep declines or a steep increase of erosion because of the increase of negative land coverage. This one is the tsunami in Indonesia in 2004, and this one is Katrina and Rita hurricanes in the Mississippi Delta area right there. And so this is a place where you can use graphs to identify phenomena. Ever thought of that? Anyway, I hope this idea of revealing the graphs slowly has given you something to think of. In the next part of this, I'm going to show you how I built this. It's actually quite easy.